Okay, so here we have a set of 5 scores, and we're going to compute the standard deviation for this population of 5 scores. We're going to start by using the definitional formula. So we always need to start by computing the mean. And the mean, you need first to have the sum of the x's. So in this case, if we add up the scores, we get 19. And then the mean, in this case we're dealing with the population, so our mean is equal to the sum of the x's divided by n, which is 19 over 5, and that gives us a mean of 3.8. Okay. Next, we need to figure out the deviation score, so figure out how far each score deviates from the mean. And in each case, we're going to take this score and subtract the mean from it. So we'll start with 1 minus 3.8, and that gives us a deviation of negative 2.8. Okay. Then we have 3 minus 3.8, which gives us a deviation of negative 0.8, and then negative 0.8 again, because we have another 3. And then 5 minus 3.8 gives us 1.2 as a deviation score. And then 7 minus 3.8 gives us a deviation score of 3.2. Right, so again, if we added up all of these deviation scores, we just end up with 0. It's a good way to check your work. Right, but to get rid of the negatives, and so it doesn't always add up to 0, we square the deviation scores. So negative 2.8 squared gives us 7.84. Negative 0.8 squared is 0.64. That twice. 1.2 squared is 1.44. And then 3.2 squared is 10.24. Okay. So the sum of the squared deviations, if we add these up, is 20.8. Okay, so that's the definitional formula. You can also do this using the computational formula, where the sum of squares is equal to the sum of x's squared minus the sum of the x's, the quantity squared, divided by n. Okay. So we already know that the sum of the x's is equal to 19, and we know that the n is equal to 5. Okay. To get the sum of the x's squared, you're going to square each of your x values and add them up. Right? So in this case, that would give us 93. Right? We're taking 1 squared plus 3 squared plus 3 squared plus 5 squared plus 7 squared. Right? And again, that gives us a sum of squared equal to 20.8. Okay? Now then, once you have the sum of squares, to compute the standard deviation, your standard deviation is simply the sum of squares divided by n. You divide by n when we're working with a population. Right? So we have the square root of 20.8 over 5, which gives us 2.04. That's how our typical distance scores are from the mean.